Hello everyone. Hi, how are you all? I hope everyone is doing great. So lovely to see you all here. So students, in today's class we will study a very interesting topic. So the topic is elimination reaction. So please note it down. Elimination, yes, reaction. Very good. So what is this? So in this elimination reaction, as the name is itself indicating that something is getting eliminated, okay. So we will understand the whole concept in detail first, okay. So please note it down. We are having a compound like this. So this carbon is there, and a leaving group X is present, okay. This is a leaving group that will be lost, right, as you can relate from this. So these are two other bonds and one hydrogen is there. Clear? Now this leaving group can be anything. So in this case, let's take an example that this leaving group is an halogen. Okay, halogens are also very good leaving group. So as you know, halogen is a functional group as well. Okay, so the carbon that is directly attached to the functional group is alpha carbon. So this carbon is alpha carbon. Okay, and the carbon next to alpha carbon is what? Is the beta carbon. Okay, yes. Now what happens? This reaction take place in the presence of a base. So we can take alcoholic KOH. Okay, this is one of the very famous base that we take for this reaction. Okay, so basically we are having KOH and we have dissolved in an alcohol, right? So that is why we are having that alcoholic KOH. So generally I can represent a base with capital B, and you know base will be electron rich. Okay, it will be having a electron pair on it. Okay, so it will abstract the proton from the beta carbon. Now you might be wondering why it is happening. So what happens, like as I told you here, in our case the leaving group is halogen. So what is happening, this halogen is electronegative, and that is why it is making alpha carbon electron deficient. And to fulfill the electron deficiency of that alpha carbon, beta carbon itself is giving electron density towards alpha carbon, right? So that is why now beta carbon is also electron deficient. And as the beta carbon is electron deficient, so what will happen? This hydrogen will be acidic in nature, right? Because the electron which is there between CH bond are basically shared towards the beta carbon. Okay, that is why. So this beta hydrogen, why this beta hydrogen? Because this hydrogen is attached to the beta carbon. So this beta hydrogen is acidic in nature, and that is why the base will abstract the beta hydrogen. Clear? So what will happen, as the hydrogen, or you can say the proton, has been abstracted from the beta carbon, so these electrons will be shifted here, and as you can see, as these electrons are shifted here, so double bond will be forming. So from here this leaving group will be leaving from the compound. Okay, yes. So what we are getting here, so I am writing here, look at this. So we will get this carbon carbon double bond, and these two bonds are there, and BH. Okay, as this base is taking this BH, it is removed, and X minus, these things are removed. Okay, so I will draw it again for you here so that you can clearly note it down. Okay, in a one line. So that was just for the explanation. I hope everyone noted this. Okay, this is very important. So please note it down again. Here I am drawing you for a, okay, here I am drawing you, again I am drawing for you. So this is the base. Okay, it is abstracting this beta hydrogen, and this is alpha carbon. Okay, and this is beta carbon, so this is beta hydrogen. Clear? These electron pair will come here, and this will go like this. Okay, and what we are getting, we are getting this BH plus X minus. Clear? So this is the elimination reaction, or the general concept of elimination reaction. Okay, yes, and we are getting a alkene. Okay, now why not we understand this with an example in more detail? So students, please note it down. Yes, so I'm having 2-bromopentane. Okay, so pentane means 5 carbon, yes, and 2-bromo, so second carbon will be having a bromine, CH3, CH, CH2, CH2 and CH3. Okay, and I'm having a base. Okay, so I'm putting a base over there. So alcoholic KOH, as I told you. So this is what I'm taking again here. So we know here this carbon is the alpha carbon. Now we have just studied the reaction, okay, the elimination reaction. Now you might be wondering that, sir, we are having alpha carbon here, but we are having two beta carbons in this situation. That is why I have given you this example. Okay, so this is also a beta carbon and this is also a beta carbon. Clear? And we know the base will abstract beta hydrogen. And one more thing, students, as this like in this reaction, beta hydrogen is getting eliminated, so this reaction is also known as beta elimination reaction. Here I am writing beta elimination reaction. Okay, yeah, so this is also a name. Okay, so please note this down as well. And why we are calling it a beta elimination reaction? Because beta hydrogen is getting eliminated. Now you might be wondering, two beta hydrogens are there, which will go, and what kind of alkene will be forming here? Think about it. Yes, very good. So here in this case we will get two products. Okay, yes, so both of them are the beta hydrogens, and there are possibilities that yes, both of them will be abstracted one by one. Okay, so based upon that we will get two products here. If the hydrogen is getting lost from this beta carbon, so we will get alkene here. Okay, so I'm writing that product CH3 CH2 CH2 CH and CH2. Okay, one product we will get this, and another will be here, right? If this beta hydrogen is getting eliminated, so we will get alkene here between these two carbons. I hope everyone is getting clear with this point. So I'm writing this compound here, CH CH CH3. Okay, so we got two compounds in this reaction, right? Now you might be wondering that, so which compound is like actually forming over there, and I will tell that both of them are forming. So what happens in this situation? Basically, we will get one compound in major and another compound in minor quantity. So this compound will be major, okay? And this will be minor. Okay, so we are getting a major product and a minor product. So what is the basic philosophy or basic formula behind that? Like from where I'm getting this thing that this is the major product and this is the minor product? I am not going into the reaction and seeing like where the molecules are getting attached and detached like this. Okay, so don't worry, a rule is there for a rescue. Okay, so what is that rule? That rule I will tell you now, so please note it down. That is very important, like super important rule. Okay, so this is a Z-Sev rule. Okay, yes, so please note it down, Z-Sev rule, or sometimes, or like people also say Z-Sev. So both the words are there, Z-Sev rule. Okay, so either you can say Z-Sev or Z-Sev, both the words are correct, both the rules are same. Okay, there is no difference. So as per this rule, what is this? Please note it down. Like in the beta elimination reaction or in the elimination reaction, we will get more substituted alkene as the major product. More substituted alkene as the major product. Okay, students? Yes, very good. So now you can see from this product is major and this product is minor. Why? Because in this, the alkene that is being forming is more substituted. How? Let's look closely. So this is the alkene. Here I am having hydrogen, here I am having hydrogen, here I am having CH3, and here I am having C2H5. Okay, in short I am writing like this. Now in this is the alkene. Look at this. Okay, so here we are getting hydrogen, 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 and here I am getting C3H 3, 4, 5, 6, 7, H7, it will be H7. Okay, yes, clear? So compare both the alkenes. This alkene is more substituted, right? Because here is the alkyl group, here is the alkyl group. Okay, so on both sides, okay, on both sides we are getting these alkyl groups. Okay, so basically there should be more number of alkyl groups, or you can say a very simple trick I will tell you, that more carbons should be attached to the double bond. Okay, double bonded carbons basically. So these are the double bonded carbons. So here I am getting one carbon over there, like directly one carbon is attached, right? For the chain is there, we are not looking at that because I am giving you a trick. So this carbon is attached to carbon. Okay, this carbon attached to carbon. Okay, and here these are attached to hydrogen. So basically here in this double bond, two carbons are coming. Now if we are looking at this example, so here only one carbon is coming in the double bond, rest three are hydrogen. So which one is more substituted? This one is more substituted, okay? So this is a very simple trick, okay? So using that trick, you can quickly find out which one is more substituted and which one is less substituted, okay? And by using the ZCF rule, we can tell which alkene will be major product, okay, in our beta elimination reaction or the elimination reaction. I hope everyone understood this concept. Quickly tell me if you have any doubt in this. Okay, all clear to everyone? If everything is clear, then I will ask a very interesting question, okay? So please note it down. Yes. So what is going on here? So I'm having a compound. The compound is, okay, this is the compound. Yes. So this is a compound, and here I'm having alcoholic KOH, okay? So we know beta elimination reaction will be going on here. So what will be the major product, okay? So the question mark is there and we have to find out the major product. So I'm giving you the options. So please note it down. Yes. So one option is this. Then option B. And option B is there. This. Okay. Then option C. We are getting, okay, this as option C, and option D, none of the above. Tell me, that's a very interesting question. Use the formula like what we have studied, the trick that I have given you. Okay, so don't worry, I will tell you how to solve this question. Look at this. This carbon is the alpha carbon, right? Because it is directly attached to the bromine, that is the functional group. It will be a leaving group. Now this carbon, can you see here? This carbon is the beta carbon directly attached to the alpha. Now this carbon is also beta and this carbon is also beta. And all these carbons are having hydrogens on them as well, okay? So there are three possibilities for the elimination reaction. Clear? Good. Now let's look at this. So one double bond can come here, okay, I'm writing one here. Okay, now another case is that the double bond can come here. And the third case is that double bond can come here. Clear? Okay. Now, if we see that the third case is there, okay, if I'm forming the double bond at the third case, look at this. So if I'm forming double bond here, so this double bond is attached to like one carbon here, another carbon here, and third carbon here. Clear? So three attachments are there. Okay. So we are taking it as a side thing. Now, if we look at the second one, so if I'm forming double bond here, so what is happening? So there are only two hydrogens and two carbons. So in the second case, only two carbons are attached to the double bond. So no, this is also not there, okay? Because the third case is there in which three carbons are getting attached to double bond. So obviously one thing we are getting, that second one is not the option, obviously, because we are getting this third situation in which we are getting more substituted alkene. Now let's check with the first one. So if we are getting double bond here, so this double bond is attached to here, like carbon, carbon, here also carbon, here also carbon, like four carbons are attached, okay? So that means this is even more substituted than the third case. So the double bond which is coming at the first case will be the answer, like out of the option, which is that? Yes, very good. So option A. So option A will be the major product, okay? We will be getting other products as well, but here the question was asking what is the major product. So that is why, because here we are getting more substituted alkene. Clear to everyone? I hope all of you have noted this question. Okay, very good. So now students, this was all about elimination reaction. Okay, so quickly I will give you a summary what we have covered in today's class. So in today's class, we have studied about elimination reaction in which we will be using a base, and base will abstract the beta hydrogen, okay? And like that, we will get a alkene as a product, okay? As a product of elimination reaction. And that reaction is also known as beta elimination reaction. Now, the alkene that we are getting will be what? Will be more substituted alkene. Okay, why? Because as per ZCF rule, like elimination reaction is happening and the alkene that we are getting will be the more substituted alkene, and that will be the major product. Okay, so that we have studied, and based upon that we have solved a very interesting question as well. I hope this concept is clear to everyone. So in the next class, we will come up with another interesting question and another interesting topic as well. Okay, students? Yes. So until we meet next time, stay safe, stay curious, keep learning. Bye everyone. Bye for now.